so we're going over number 12. So for 12, first I'm going to read the question. So the question says, what percentage? Whoa. So I know that I'm looking for a percent, which means that first I need to develop a fraction. And so it says out of the number of students in the freshman group. So out of that many students, so first I need to add these three numbers up, and I know that's going to be my denominator. When I add them,
72.
I end up getting 72. So out of that group, it says how many think it's mandatory or agree that it's mandatory that they should participate in a sport. So out of this row, so I don't even need to look at the rest of this table. Out of those 72, 53 of them agree that it should be mandatory. When you do this, I get my answer and then I press second and the end parentheses, and that turns it into the percent. You end up getting this answer right here, 73.6%. Next one, first remember that we read the question, it's asking about the median. So I know that I type my answers into data, into L1, and then you press second data and enter 4 times, and when I get to the median, I can see that it was 69. Part B is saying explain why the median should be used instead of the mean. And so we remember, okay, we always use the median when there's an outlier, which is a number way larger or smaller than the rest of your data, or when your data is skewed, so skewed left and right. When in doubt, I would always pick median. The only time you would pick the mean is when the mean equals the median. So when I'm looking at my data, I could see, okay, is there an outlier in this data? Yep, there is. 158 is way larger than the rest of those numbers. So I know that since 158 is an outlier, and it skews the mean. That is why the center of the data is higher when Jeff found the average. And because Maria noticed an outlier, she realized that she would use the median to describe the center of the data. So this is the exact answer that the EOC came up with. So that's the type of answer they're looking for when they're asking you questions like this. All right, irrational, rational. So remember, rational is short to the point, right? It's a terminating decimal. That means it stops. So short, sweet to the point. It's also a terminating decimal, which means it stops. And it can be written as a fraction. An irrational number, I'll write it down here, is a non-terminating decimal. It's a number that goes on forever and ever and doesn't repeat, and it cannot be written as a fraction. So it's just the opposite of all rational explanations. So when I look right here, I look, okay, radical 3 minus radical 3 equals 0. 0 is a terminating decimal, 0.0. So I know that's rational. Right here, when we see multiplying, I multiply these two to get radical 36 over 5, which the square root of 36 is 6. And since this is a nice little fraction, I can see that it's going to be a rational number, so I cross it out. Next one, when I multiply 2 times 8, I get radical 16, which is 4. And 4 is a terminating decimal, so just 4.0. So that's rational. My irrational number is this because when first of all, radical 7 is not a perfect square. If I add 4 to it, it's just going to add 4 to that answer. I could also put it in my calculator and see it goes on forever and ever, so I know A is my answer. Next one, I can see average rate of change, so I should look at my formula sheet and I can read that I'm talking about slope. And remember, it's between these 2 points, so I'm only looking at when x is -1 and when x is 1. So I would write down my points like this. Next, I would label. So I remember I label x1, y1, x2, y2, and then you plug it into the slope formula. When you do that, you get -1 minus 5 over 1 minus -1. And that slope formula formula is given to you on the formula sheet. You end up getting -6/2, which gets you -3. So C. Next one we went over, but remember we can always do the table twinsies, but you also know that you can factor. So you find your A is 1, your B is 8, your C is 15. When you do this, you do 1 times A times C goes at the top, and B goes at the bottom. 1 times 15 is 15, and then 8. So I figure out, okay, what two numbers multiply to 15, add to 8. I would figure out that 5 and 3 are my two answers. That's why these two, your factors, are x plus 5, x plus 3. You could also look at your zeros in the calculator. Your zeros should have been -5, 0, and -3, 0. And I know my zeros and my factors are opposites. Next one, I can use calculator twinsies also, but you can also look in your table. And when you're looking at the minimum, you're finding the vertex sandwich. And so at -4, -1, you should be able to see, because it was -5, 0, -3, 0. So on your table, it should look like this. And that, since this is a sandwich that's getting smushed by the zeros, I know that that's my vertex. So the opposite, remember this is opposite day, so the opposite of +4 is -4. And the same as -1. This one, you would do the same thing, so you can factor and find your zeros. You can use your calculator to find when your y is 0. You can use quadratic formula, any of those things you can use to find your zeros, and they end up being 2 and 4. So here's the explanation if you'd like to see how you can do that. The next one is looking at x squared, so they're asking, does it have a minimum and not a maximum? How do I know that? I know because my leading coefficient is 1, and it would look like a positive Patricia. So because it's positive Patricia, I know it would have a min as my vertex over a max. I also can look at my calculator and see that my lowest point would be -1, and then it goes back up. So because of that, positive 1. So because 1 is the smallest y value that there is, I know my minimum value is 1, which is your y coordinate of your vertex. Next one. So first it asks, what does the x represent? So I look and see, okay, here's a 10 in x, and I can see here it's 10 cents for each bottle he recycles. So I know that 10 represents a cent, so that means the number of bottles Sean recycles has got to be my x coordinate. To find your point of intersection, you can use substitution or elimination. I would use elimination because both equations are in standard form. So first I find a coefficient that, or I figure out, okay, what do I want to play around with, the x's or the y's? I'm going to play with the x's. So if the bottom one is -10x, I need to have them be the same number, opposite sides. That means I need the top one to be +10x. So when I do that, I know I need to multiply. Actually, I lied. This one will be +10 because it's already +10. I don't need to do anything to it, which means this one should be negative. So I'm going to multiply this top equation by -10, so that -10 times x can get me that term that I need. But I need to make sure I remember to multiply to each term in here. So -10 times y is -10y. -10 times 210 is -2,100. I don't need to do anything to this bottom equation, so I'm just going to rewrite it. Then I know that in order to eliminate my x's, I need to add the two equations together. When I do that, that eliminates this because I get 0. When I add down here, I get -5y. And when I add down there, I get gets me -825. To get y by itself, I divide by -5. And I end up getting y equals 165. So when I go up to my answer, because they just want a point, I know that when I write my answer, 165 is going to be my y coordinate. To get my x coordinate, you can take either equation, so I would take the original ones. So I'm going to take the top one because it's less coefficients, less numbers involved. And instead of y, I'm going to plug in what I know y is, which is 165. To get x by itself, I subtract 165 on both sides. And you end up getting x equals 45, which is my x coordinate. Remember that make sure when you check your answers, plug in 45 for x and 165 for y for both equations to make sure they're true. So this one, when I plug it in, should equal 210. This one, when I plug it in for x and y, should get me 1275. That's important when you're checking your work to make sure that you've got the correct answer. 19, you can do table twinsies, or I can multiply. So x times 3x is 3x squared. X times 1 is 1x. And I do the other one. 2x times x is 2x squared. And 2x times 3 is 6x. Then I combine like terms, so I can see, okay, 3x squared plus 2x squared, they have the same last name, is 5x squared. And then 1 plus 6x is 7x. So I know that one's my answer. Next one says, first let's figure out what the question is asking. So part A says, Lamar determines the rate at which he's calculating the slope on the graph. The slope is about 0.4 feet per hour. Explain why the unit rate for the graph could be 0.4 square feet per hour. And that's because when I'm looking at the graph, I can see this is the only point that's really on, which is 5, 2. I know that my slope is the change in y over the change in x. So my y value right here is 2. And so this is 2 feet per 5 hours. So that's my unit rate. And then, so when I'm finding my unit rate, I would do 2 feet per 5 hours. And so when I have to figure out, okay, how many feet per 1 hour, I would divide it and get 0.4 feet per 1 hour, which is why I can use the unit rate to explain it also. And so that's this first answer right here. The next one I'm looking at is part B, and they're asking me to put it in from inches or feet to inches. So I know if it's 0.4 feet per hour, they want you to get it into inches. So I know my conversion ratio is 1 foot equals 12 inches. And so feet's at the top here, feet goes on the denominator here, so 1 foot is 12 inches. And they want feet per, or inches per hour. So let's make sure we end up with those units. Yes, we do. Now we multiply across, so 12 times 0.4 ends up getting me 4.8 over 1 times 1 is 1. And so your answer is 4.8 feet, inches per hour. Last two questions. This one, they're looking at the end behavior, similar to one we had earlier. We know end behavior has to do with our asymptote, which is our end, where the parabola is ending or taking off. And so we can see our asymptote is when y equals 2. So I know that's also the end of my equation, so I know I can cross out C and A. Then I need to figure out, is this equation represent growth or decay? I can see it's decay because it's going down, which means it's the b has got to be less than 1. So I need to figure out, okay, 1.1, that's my b, that means growth, so it couldn't be that one, which means this one is decay because 0.8 is smaller than 1. Last part of this is they're asking which one has a y-intercept of 1. We already went over it, but y-intercept, oh, why can I never remember this? When your x is 0, they're looking for which one of these gives you 1 as your y coordinate. So the only one would be D, because when I plug in 0 for x, anything to the 0 power is 1. 1 times 0.5 is 0.5, plus 0.5 gets me 1. Or you can always put it into your table, or plug in 0 for each of these x's. figure out which one gives you 1 as your answer. Cool. So make sure that you guys are paying attention to your formula sheet. I'm going to go start. All right, so now the formula sheet, when we're doing that quizzes, it's helping us come up with our little cheat sheet. So as soon as you get your formula sheet, I would definitely write down important things to remember. And the first one would be, okay, rate of change and slope are right next to each other. They're besties. That's because rate of change means my slope. It also tells me that it's the change in y divided by the change in x on a graph. Slope, it's telling me here's the formula. My m is right there, so m represents my slope. So when I see an m like that, that's my slope. It's the one coefficient of x. But it doesn't tell you how to label, so make sure you know to label x1, y1, x2, y2. We also know that there's 2 different rates of change. There's variable and constant. So linear has a constant rate of change. It's always your slope. Exponential. So exponential and quadratic change depending on the interval, so that would be a variable rate of change. When we're also looking at linear, we can see the word line, because a linear equation looks like a straight line. Point slope we didn't go over in this class, so you can cross that out. Standard form is what we use when we're using elimination. They both need to be in standard form. So that means that x and y are both on the same side of the equal sign. When I'm looking down here, also I see there's arithmetic. Arithmetic and linear are besties because they are the same. Arithmetic are numbers that are adding or subtracting over and over. When you're writing a recursive or an explicit equation, notice that there's a d plus d right here. That's the most important thing. All d is your slope. So d and m are exactly the same thing. It's your common difference, but it is your slope. It's what's getting added or subtracted each time. Your b here, I'm going to go back to this original equation. This is your y-intercept. It's your beginning value. So if we're looking at word problems, or OY, it's when your x is 0. That's for linear. Over here, the only other thing you would need to fill in is A1. A1 is your first term. That doesn't mean your y-intercept. It's when your x equals 1. So it'd be 1 comma whatever the number is. If they're asking for a certain term number, I would plug that in for n. So if they're looking for the 100th term, I would plug that answer in for n. So term number. Those are the only things you should be filling in. So like if they wanted you to write a recursive, you're not filling in any of this. It just means to get the next term, I take the term before, and I add or subtract whatever the slope or common difference is. This one's saying to get a number term, so like either to get the 100th term, I would take the first term, add whatever term I'm looking for minus 1 times whatever my slope is. So it's just kind of to get you a certain number term. Cool. The next one, we went over exponential. We know that exponential means multiplying over and over. I can remember that because of this x in there. There's an x in the exponent, exponential. So that little x, if there's an x in the exponent, I know I'm looking at this formula right here, exponential. Your b is your growth or decay factor. So what's being multiplied over and over again? Remember, if it's larger than 1, it's growing. If it's smaller than 1, it's decaying. Your a, just like above, but now it's a, not b. A is your y-intercept. Your initial amount, OY, is when x equals 0. Or your beginning amount, initial. Geometric and exponential are next to each other because they are the same. So exponential and geometric. They're besties because they are the same. So if they're looking at geometric, they're talking about exponential functions. Again, all you're filling in this time is your r. So your r is just is the same as your b, it's your growth or decay factor. So what it's being multiplied over and over again. Your a1 again is your first term. You're just plugging in what you know. Compound interest. We'll skip that one for now. Quadratic equation, standard form. Remember, quadratic is when there's a 2 in the exponent, so it looks like this. Remember, A is your leading coefficient. That means when I'm looking at A is your leading coefficient. It's either a positive Patricia, so it's either facing up, or a negative Nancy facing down. So that's your leading coefficient. These is. In standard form, remember, in order to put it in our calculator, it has to be in standard form, so you need to move everything over to one side. Right here, I can see my C is my constant. It's also your y-intercept. So it's OY. Your y-intercept, your constant, is your C. Vertex form is giving you the vertex. So your vertex is actually the opposite of whatever's in here, and whatever the same sign as this right here. So if my equation was y equals x plus 3 minus 2, I would know my vertex is the opposite of whatever's in here, so negative 3, and the same as what's right here, negative 2. That's your vertex. Remember, your axis of symmetry is your x coordinate of your vertex. So here my axis of symmetry would be x equals negative 3. Quadratic formula is this, so this gets you your x-intercepts. So y says x, it gives you your x-intercepts. So does the table, but you can always use this equation by clicking ND. Make sure it's in standard form in order to start labeling. The outside of this also gets you your axis of symmetry. So negative b over 2a, that little part also can get you your axis of symmetry. Moving up. They also give you your mean, which they're saying, okay, this is what it looks like in the calculator, so I could find that in data. But we add all our numbers up and divide by the number of terms there are. Interquartile range we know is our Q3 minus Q1. It tells you exactly what it is. Mean absolute deviation, they tell you it's the sum of the distances between each data value divided by the total number of data. So in case this is on there, we've gone over it. Remember, we take our mean, we subtract our mean from each of our values, that's what this is right here, and then we find our mean of that number.